Okay, so today we are starting with 3D shapes. All right, so we have these are known as polyhedrons. That's what we're looking at right now, and is a 3D figure whose faces are polygons. So the face is a polygons that make up a 3D figure. The edge is the intersection of the two faces, and a vertex is a point where the edges meet. Go ahead. So if you look right here, like this, that's colored in blue, that is the face, okay, of the polyhedron. The edge, remember, if this is a face, and that's connecting, that's our edge. And then the vertex is still has the same definition as if it was a 2D shape. All right, anybody still writing this down? Yeah? Okay. Anybody else still writing? Okay. All right, so first 3D figure we're going to discuss is the prism, okay? And is a 3D figure with two parallel bases, and the prism is always named by the base. So you need to identify bases, so be careful with this, okay? If we look at this would be known as a triangular prism because the triangle makes up the shape. This one would be probably a square or rectangular prism depending on what you're given. But again, this shape and this bottom shape make up the name. This would be a pentagonal prism because the pentagon is the main shape. Okay? Questions on this? Okay, let's take a look at these examples. So, if we look at this, the main base shape is a triangle, so we call this a triangular prism. Here, the main base shape is a pentagon, so we call it a pentagonal prism. Here, the main base shapes up and down are rectangles, so we have a rectangular prism here. Questions on this so far? Is this making sense? So prisms have those two parallel bases, okay? Now we're going to talk about a pyramid. And just like the pyramids of Egypt, they all come to a point, okay? If you looked at the pyramids of Egypt, they were probably more like rectangular or square pyramids, okay? In this case, a pyramid is a 3D figure with one base and a common vertex. That common vertex is where all those edges come and meet, okay? This is also named by the base. So if you look here, this would be a triangular pyramid. This would be maybe square or rectangle pyramid. This would be, let's see, you got 1, 2, 3, 4, 5 sides. So this will be a pentagonal pyramid. And this has 1, 2, 3, 4, 5, 6 sides. So this would be a hexagonal pyramid. What I'd like you guys to do is in the next example, why don't you name these three pyramids for ABC? All right, are we ready to check the answers? Let's see how we did. All right, so if you look here, this is a square pyramid. It's definitely a square because you have these 4 tick marks. Okay, so you know that all those sides are congruent. This is a pentagonal pyramid because, again, 5 sides, and this is a hexagonal pyramid because of 6 sides. Any questions? Okay, let's talk about these next ones. So, naming these 3D figures is, you got to think of it this way. You have that base shape, right? Well, circles are a shape. Circles can act as a base shape, so they take on a different name. If you look at this first one, this would be also known as a circular pyramid or a cone. We have a circular prism, or we call it a cylinder. And then we have a sphere. Nothing we can really do with that except call it what it is. Okay. Okay, let's talk about cross section. So 2D shapes, that is the intersection of that figure and a plane. All right, so if we take a look here, okay, we see that if we do a cross section and we look at it in the 2D shape, okay, so think of it this way. I have this nutty bar, right? Let's say that this was all just one rectangular prism, okay? I do a cross section and I cut it. This part right here is the cross section, okay? So what is the shape of that cross section? A what? Right here. What is it? It's a rectangle. That's it. Okay? If I cut it this way, what else am I getting? Is it what's the shape? It's a rectangle again. Okay? If I cut an orange and I looked at it, what would it be? A circle. Do you guys? That's what a cross section is. It's just basically how you cut it determines the shape that you're going to get after. Okay. All right. So I'm going to try getting this real quick. I want us to watch this. Okay, so let's take a look at this. Providing it will actually work. Okay, so cross sections, obviously they're in the world like they just said. Okay, MRIs are a great example of that. They literally, what an MRI does is it takes a picture of you like this and turns it like this. It's pretty cool. But what you're going to see in algebra 2 are the cross sections of a cone. Okay, and this is one of those cones. All right, this type of cross section where instead of it going parallel or vertical, it's kind of going on this weird angle, which is forming, this is known as an ellipse. If we look at it, we can see kind of how it gets to that 2D figure. Okay, but this is known as an ellipse, and you're going to have to graph those next year. I'm not sure about this year because we're still working on some stuff. Things take for, well, I don't know if this is working. All right. So here's the cross section of a triangular prism. Let me see if I can zoom in on this a little bit. Okay, if I rotate this, you guys see how like the triangle gets elongated? If I adjust the height, we still see that triangle. But remember, cross sections can also happen on different angles. Okay, here's our vertical cut, how it changed to a rectangle, and so on. Okay. Here's one of a pyramid. All right, so if we look and we just go up, down, we just see that we're getting like a bigger or smaller square. If we tilt this though, notice how we start getting a trapezoid. And then we get a triangle again. If we turn it, notice how the triangle gets wider or smaller depending on the turn. So the type of shape you get is going to be very dependent on how these cross sections are set up. Okay. All right, so that's all we have on cross sections. Let's talk about rotational solids. So a rotational solid is a 3D solid formed by rotating a figure around a given axis. They talked about that when a lot of time they talked about that in the video, and a lot of times that's how we get cones. That's how we get cylinders. That's how we get, a lot of the circular shapes. Okay, so rotating a polygon about an axis forms a 3D figure with at least one circular cross section. So in this case, if we took a right triangle and we rotated it around an axis, that's how we get a cone. Okay? This is known as the axis of rotation. It doesn't have to be on a coordinate plane to be an axis. It just has to be a guide so that things don't kind of go off course. Okay? As the triangle rotates, each point on the sides traces out a circle about the axis of rotation. So if this is our triangle, and we know it's isosceles because we have two tick marks here, and we spin it, we get a cone. All right, let me get the video for this one. All right. Okay. So let's take a look at these three-dimensional shapes. Okay, so what kind of solid is this going to give us? Who could tell me once I rotate it? Give me an idea. It's something you put ice cream in. What? Cone, right? Ice cream cone. You guys ever have an ice cream cone? Yeah, right? Sugar cones are the best. All right, so if I rotate this, we see it going around and around. So we're going to show the solid now. This is how it looks. So if I got rid of this, see, it just keeps going and going and going. Okay? Let's see the rotation of a circle. So if I rotated a circle, you see how this keeps going and going around? That's going to give us a sphere. And the rotation of a rectangle, it should give us a cylinder. All right, questions on this? All right, get going on your homework.